Alrighty, so I know you guys hopefully just finished or recently finished watching the YouTube video that I shared with that British guy talking about Euler's number E. So that was just a quick video to introduce you to what E is and what it stands for, the value. And now I'm just going to do a few examples so that you guys can see how to use this number in actual problems. So it's not an uncommon number. In fact, it's oftentimes referred to as the natural number because it did appear naturally in the, as you guys saw in the problem from that YouTube video. So we saw that this had a value of about 2.718 something. So I just want to remind you guys that when I say every time we see the letter E or talk about E itself, we are talking about a value, 2.718. Just like when we talk about pi, yes, we're used to hearing the word, we're used to seeing the symbol, and it's important to remember that that's specifically representing a very important value in math, 3.1415 ... So E is another one of those very common constants in math. We just haven't really seen a lot of it up until now. So the first thing I'm going to do is a quick example, and I want you guys, I know I don't have video or notes packets that I handed out for this, but I do want you to just take notes by hand with me as we go through this. And the benefit of this is that you guys can pause the video if you feel like I'm moving too fast or you don't have time to write. Just pause the video, get things written out, stop yourself and check for understanding, and then move on as you need to. So I'm going to start with a very simple problem that is total review for you guys. So if I have a problem like this, 2 raised to the x equals 23. Okay, so hopefully you guys remember solving simple exponential functions simple exponential equations like this. So if we are solving for x and it's in the exponent, we now know that when we take the log of both sides, that one of the properties of logarithms allows us to take that x down out in front of the log. So I'm going to work through this step by step. So I take the log of both sides, and then like I just said, that means this x, whoops, sorry about that. Okay, this x right here can come down in front, and we really have x times the log of 2 equals the log of 23, and then we can simply divide both sides by log of 2, and we get log 23 divided by log of 2, and then we can just quickly get that value on our calculator, and we can, actually I haven't done that on my calculator. So log of 23 divided by log of 2. That's about 4.52. So I do this problem just as a quick reminder of solving exponential functions with logarithms. Okay, so I'm going to switch gears now and kind of revisit a property of logarithms. Really, it's kind of like what logarithms, in a way, how they're defined. I'm going to do that over here in this little box. So I just want to start by writing this out. Log, now, when we don't write, I'm going to just say log of 10. When we don't write the base of the log, remember, logarithms are the inverse of logarithms. So even logarithms have bases, and the base of a log is usually written there, and if it's not, you hopefully remember that that means we assume that the base is 10. And so when we're looking at an expression like this, we would ask ourselves, if I set this up and asked what this was equal to, what does this equal? Well, remember, we would say, okay, the base of 10 raised to what power equals 10? So 10 to what power equals 10? And that's obvious because that would just equal 1. So what if I wrote another problem but changed the base? What if I said log base 3 of 3? What would that equal? Again, using that definition of logarithms and how they relate to exponents, this is 3 raised to what power equals 3, and that's just 1. So this is one of those properties that the log of any number, or base of any number of itself is always going to be 1, and that's something we're going to utilize here in a second. Okay, so what I'm going to do now after that little side note is I'm going to do this problem again, and I'm going to apply what I just covered in that little box. So we're starting again. This is still number 1, 2 raised to the x equals 23. So since I just kind of reviewed over here that the log of a base a of a, so let's say, log base 10 of 10 equals 1. Since over here in number 1, since my base of the exponent is 2, let's think about using log base 2 of 2 to the x. So think about what that will do. So if I do log base 2 of 2 to the x, and then I have to do that to the other side as well, log base 2 of 23. So this is just an alternate way of solving it. Then I could, as we know, this exponent comes down in front, so it's really x times log base 2 of 2 equals log base 2 of 23. But like we just saw, the log base 2 of 2, 2 to what power equals 2, that's just 1. So this whole thing just equals 1. So I really just have x times 1 equals log base 2 of 23. Now that doesn't look exactly like our answer over here, log of 23 divided by log of 2, but we could get it there using the change of base formula. So you may not remember change of base formula. We did cover this earlier in the year, but it said that if you have the base log base of something other than the one you want, there was a way to show that that ended up just equaling the log base 10, or any base we want, of 23 divided by the log of the old base, log base 10 of 2. So with this other way of looking at it, this is just giving us another option on solving exponential equations, because we could take the we could use log of any base depending on the base of our original exponent. So that's going to kind of lead into some of the problems we see moving forward. Okay, so let's do another example, and we're going to apply what we just talked about here. So number 2. Number 2 is e raised to the x equals 4. Okay, so now we're introducing e to an exponential equation. So remember, e itself is just the value 2.718 something something something. So don't forget that. I'm just going to add another little box over here. So e is Euler's number, and we saw from the previous video that it is 2.718 dot dot dot. It's an irrational number, and meaning it never terminates, it goes on forever. So that's what the problem we're solving is, that number 2.718 raised to what power equals 4. Well, let's just think about this logically. We know that e is almost 3 or 2 point something, so it definitely, x cannot be any greater than 2. It can't even be 2, because we know that 2 squared is 4, so 2.718 squared is going to be larger than that. So we are going to apply what we just saw in the problem above. If I have a base of e, then I can undo that. In wanting to solve for x, I can actually undo that by applying log base e of e to the x. And as long as I do that to the other side, log base e of 4. So the reason, again, for doing that is this x can come down in front. And think about what log base e of e equals. That's e to what power equals e. That's just going to be 1, because we saw that over here. Log base a of a is always 1. So this is actually going to simplify to just x times 1 equals log base e of 4. Okay, so let's stop right there. How do we evaluate log base e of 4? So the thing about this number e, it is so common that it is actually built into our calculators. We just haven't really utilized it yet. So I'm going to stop and get a picture of a calculator first to show you guys. Okay, so we see my calculator on here that I just got a clip of from the internet. And I'm going to zoom in, ignore the graph up there. Sorry for tilting it. I'm going to zoom in here and show you guys. You see the log button right here, right? Let me switch my pointer a little bit bigger. All right, so we see the log button. That's log base 10. Above it is 10 to the x because those are inverses. Right below it, you see this ln. And then above it, you see e raised to the x. ln actually represents natural log, and that is log base e. So log base e is so useful. It gets its own button on the calculator. It's super useful. You may not have thought that up until now just because we've never used it, but that's just because it just hadn't been introduced to you yet. So this button right here will evaluate log base e of anything. It may seem weird because it is ln and not nl if you're thinking natural log. But that's probably because a lot of our math words come from Latin words, and that I think they switch around order of words, so they might have used natural log whatever instead of or logarithm natural instead of natural log. So that's why. So what I'm going to do now is this is the important step here. Log base e of 4 is actually the natural log of 4. So that means in your calculator, all you have to do is type ln, and when you do that, it'll allow you to type in the number 4, and then you can solve. So x equals natural log of 4, which is about 1.39 for this problem. And then I'm actually just going to add in another little important box section here. And something I want you guys to add to your papers is this, that log base e of x is actually the natural log of x. So anytime you see ln, logarithm natural, I'm assuming, that is natural log, which is just log base e. If you feel more comfortable writing log base e for a little bit, that's fine. But you do need to grow kind of in the ability of using ln for natural log, which is log base e. Okay, so I'm going to do just a couple more problems and leave it at that. I wanted you guys to have a very basic intro of what e is and how we can use it to solve exponential equations. So let's do a couple more examples here and hopefully let this sit a little bit in your brains, and then you can practice a couple of problems on Delta Math. Okay, so let's do number 3. This will be 5 times e raised to the 2x equals 1. So 5, I'm going to scoot this down. So in solving for x, we got to start it with the basics. Again, we want to get x by itself. Right now it's in the exponent. Eventually we're going to need to use logs. But before we can use logarithms, we kind of have to isolate or get rid of this 5. So the first thing we would do here is undo the 5 times e to the 2x. So we would just divide both sides by 5. And now we've got e raised to the 2x equals 1/5. Or 0.2, however you want to write that. Okay. Now, to undo e raised to the 2x, typically at this point what we would do is take the log of both sides. But as we saw above, if I take the log with the same base as the base of my exponent, that's going to quickly eliminate the use of any more logarithms. So I could just take log base e, and I'm going to use log base e just this one time. Log base e of e to the 2x equals log base e of 1/5. So we already saw many times that this 2x can now come down in front, and I have 2x times log base e of e, which is just 1. So really, it's just 2x on the left-hand side. equals log base e of 1/5. Then I would just divide by 2, and then I would evaluate this whole thing in my calculator. But remember, log base e is built into our calculator, so that's easy for us to do. So you would type the ln button, ln on your calculator. Then on your screen, you'll see ln, and then you'll see this, and you would just type in 1/5, close the parentheses, and divide by 2. So I didn't write ln originally in this problem, but at this step, what I would have done, what you'll see me do moving forward, when we had e raised to the 2x equals 1/5, at that point I would have said, okay, since I have a base of e, I want to take the natural log of both sides. Natural log of 1/5. So it's the same thing. I just stuck with log base e one more time, so I want you guys to get comfortable with what ln means. It means I'm taking log base e. So once we do that, again, the rest of the problem follows. You would have 2x times ln of e, when I bring this down, equals ln, or natural log of 1/5. Again, ln of e, that just equals 1. Why? Because it's really log base e of e, and e to the power of 1 equals e. So that's why the natural log of e just equals 1, which is why I took the natural log of both sides. So I'm just redoing this problem using ln so that you guys can grow comfortable with that. And then typing in my calculator, I would first type in the natural log of 1/5. Natural log of 1/5, hit enter, then divide by 2, and we get x equals about negative 0.805. So I would double check on your calculator, just make sure that you're typing the correct buttons for that as well. Okay, just a couple more examples here to get more comfortable with natural log. Whoops, okay, sorry. This is getting weird. How can I move that up? And then this up. Okay. All right, so got a couple more examples for you. I think we're on number 4. And unlike number 3, so back up here to number 3 where I started with e raised to a power, now I'm going to kind of go backwards, and we're actually going to start with the natural log. So I'm starting my problem with natural log of x equals 3. Just a reminder, this is log base e of x equals 3. So when I look at this, I'm not going to be in the habit, I'm not going to write log base e every time, but I'm doing it again so that you guys can visualize what I'm going to do next, which is this means that the base of my log, which is e raised to this power 3, equals x. Why do I do that? That's because here's my base, e raised to the power 3 equals x. So then I can just rewrite it like this, and now all I have to do to get my numerical value of x is use my calculator, and the button on that is, just had to pull up my picture again, right here where you see ln. So if I want to enter e raised to a power, you're going to hit the second button, and then the ln button, and then you can type in e cubed. So you'll hit second, hit natural log, and then you'll have a little empty box blinking, and you can just plug in 3 to get the value for e cubed. So we enter it into our calculator, and it is about 20.086. Again, I would encourage you to go through that process on your calculator just to make sure you can use it correctly. I know I've said this several times. When we type in that e on our calculator, remember, we are actually representing this irrational, never-ending number. We actually plugged in 2.718 ... raised to the third power. So I just want to remind you over and over that this letter e, while it can get, the meaning of it can get lost in the process sometimes. That is this very specific number that we're using. All right, one last problem and then we'll call it a day. I didn't want this video to be too long. All right, so I'm going to use one more problem. So I'm going to do 1/3 times the natural log of 3x plus 2 equals 2. So I'm solving for x. Right now, x is stuck inside this natural log function. So if I can get rid of this 1/3, then I can kind of rewrite this as an exponent. So if this whole thing is being multiplied by 1/3, we would want to probably divide it by 1/3. I don't like dividing by fractions, so we could also just think of this as multiply both sides by 3. When I do that, this 3 and this 3 cancel out. I'm left with the natural log of 3x plus 2 equals 6. And then here we just have natural log of something equals a number. Well, this is the perfect situation to rewrite this. The base of the log to the power of 6 equals 3x plus 2. What is the base of natural log? Hopefully you just said e raised to this power of 6 equals 3x plus 2. At this point, again, you would just use your calculator, use that button. You would hit second ln to get e to a power. You would plug in e to the 6th, and it's 403.429 equals 3x plus 2. And then we can just continue solving this algebraically. So subtract 2 from both sides, and you end up with 401.429 equals 3x. Then divide both sides by 3, and we end up with our solution for x. So 401.429 divided by 3, 133.81. So that is our approximate solution for x. Hopefully this is all making sense to you guys. Once again, do not hesitate to shoot me a message if you just need some clarification on this. I'd be happy to respond, schedule a Zoom call, whatever we need to do to help you guys moving forward. All right, talk soon.